Hello everyone, and welcome back to NetMastery Zone channel. In this video we are going to continue our CCNA course, and if you saw the last video, we just designed this simple network here, and we also configure some VLANs in both sides, and also we speak about the different mode of the ports. And if you remember, we just create some trunk port here, and now these two ports are trunk, and they are sending the all information from all VLANs from one side to other side. And we also speak about the spanning tree actually a little bit. And in that we said the spanning tree is a protocol that is used to create a loop-free path for our traffic. And let me just speak about more about that. You see that when a switch send a packet, for example, this PC wants to send a packet to a PC for IP address of 200, and this IP address 200 is not actually available in this network. In this case, the switch is sending this traffic, and this traffic actually come through this port to this switch. And this switch see that because it doesn't have that IP address, it cannot find the destination. Then it's trying to send it to another switch to make sure that actually it's the job of the switch to send it to another switch to find the destination. And the switch is designed to just send it when you receive a traffic from one interface. For example, this interface gigabit 0x1, it never send it back to that interface, but it will send it to another interface. For example, here in gigabit 0.02, and when it send it back to this switch also doesn't have that IP address, and then it send it back from this link again. And it will be an infinite loop between these two switches, and it will take the whole process of the switch, and the whole network will be down just in a second. For solving this problem, actually the Cisco not the spanning tree is not only Cisco, it's a open standard, and they just design a protocol to actually remove this loop from the switches. Now in this case, you can see that the spanning tree is run here, and the spanning tree just block this port, and anything for example, this switch sends something to this, and when this switch try to send it back, it just this port is blocked, and the packet will drop here and will not make a loop. But this design actually it's good here. Actually it's a need, it's very necessary here to be something like this, but one of these ports actually is just it's in the standby mode, and we never use this port. And assume that we may have some for example security camera here, and the security camera is going to send a lot of high quality images and videos from one side to other side. In this case, we may need more bandwidth here, and only one port of gigabit is in use, and that port may not be enough for sending all this traffic from this side to this side. Because of that, we have another protocol that named port channel. Port channel or ether channel, it's actually aggregating this port together and make one big port. For example, here we have two 1G port, and if we configure the port channel here, this two 1G port become one 2 gigabit port, and then this traffic can be sent from this side to this side. And also because it's become a one port, then there is no need for any spanning tree, and the spanning tree doesn't have to do any job here because it's only one link, and it will never make a loop. Okay, let's go to our presentation and see what kind of port channel actually we have. Here you can see that what I discussed here. You can see switch 1 and switch 2, and they are connected with 4 gigabit link, and for 1 gigabit links they are physical links and they are connected together. But if we actually configure the port channel here, then we will have one 4 gigabit Ethernet link, and that's a logical link. It's not a physical link. It's combine this all together and make one logical link, and then the traffic will send from one side to other side using these 4 interfaces. Actually, the packets will be divided in different frames and will send to other side. Okay, what modes actually in the Ether channel we have? We have PAC-P mode, LAC-P mode, and ON mode. The PAC-P mode is a Cisco proprietary protocol. It's designed by Cisco and it's only working on the Cisco switches. The LAC-P is open standard, IEEE standard, and it's used for almost all vendors as a Ether channel. And the other mode that we have here is ON mode. This mode doesn't negotiate anything about the Ether channel, and just send the traffic, just build the Ether channel port between these two switches without any negotiation. Okay, the PAC-P is stand for Port Aggregation Protocol, and PAC-P, as I said, it's a Cisco proprietary protocol, and it's used for and it uses multicast address of this for communication. Okay, let me see what is this actually, why we need this multicast MAC address here. Because in the PAC-P we have to, when we try to configure this PAC-P, we have two different modes. We have desirable mode or we have auto mode. If we put our switch in the desirable mode, then desirable port actually trying to discover any other port that is configured for PAC-P. It means it's going to send a packet using this multicast address to all switches that this port is connected. Then if we discover any other site that is configured with the PAC-P, then it will build the Ether channel between these two switches. As you see here, a port in the desirable mode, it will automatically and sending the packet to other side. And the auto mode just wait, it doesn't send anything, and just listening to the I can say the packet. If any packet comes from other side and it has contained the information about the Ether channel, then it will try to build a channel between these two. Okay, before we go to the LAC-P, let's first configure this, and then we'll come back to the LAC-P again. Okay, for that let's first go to the our switch 1 in the first floor and try to configure the Ether channel here. Let me enable that password, and then let's go to the configure terminal. For configuring the Ether channel, we need to actually go to these interfaces and configure this Ether channel in these two interfaces. For that, let's take a range of these interfaces, gigabit 0x1 to 2. Now the command is the channel group. Then we need to give a number for this, and in the packet tracer it just supports from 1 to 6, but in the real switches you can see a higher number also. You can make 30, 50 and so on. I'm going to use 1 here, and now you can see that we need to select the mode for this Ether channel. Let's select the mode and see what we have here. We are speaking about the PAC-P. We have the auto mode and we have the desirable mode. The desirable mode actually enabling the PAC-P unconditionally. It's enabling the PAC-P and trying to send the packet to this multicast MAC address. If this is a multicast MAC address, and if any other switch is configured for PAC-P, they understand this actually this information when they receive. And when the other side, for example, we configure that as a auto, in this mode, the enable the PACP only on if the PACP devices is detected. It means it's just waiting, and if it detects any PACP device for in the other side, then it just enable the PACP. For that, it's very important that we use one side, at least one side, as a desirable. We can configure both sides desirable, there is no problem. It's enable the PACP unconditionally and they build a port channel. But if we configure both sides as auto, then both of them just waiting to receive the information, because they are auto and they just sit down and just listening to the traffic when they come, and if it's about the PACP, then they try to build a port channel here. Then let's enable in this side desirable. Okay, now the port channel is enabled here. You can see that this port is just flipped, and now they are in the orange state. It means that now they are sending the traffic to the other side to discover any PACP if it is enabled in the other side. Let's run some show command here. Do show run. Here you can see that now we have the port channel 1, and if we go to the other ports, these two ports that we configured before, you can see that the channel group 1 mode desirable is configured here. By now this two port actually send the traffic, but because they didn't receive any information from that side, they just get back to their own state, and now there is nothing happened actually. The port channel is enabled here, but because the other side there is no port channel, they are just doing their own job and they are working as a trunk here. Okay, let's do something else. Do show IP interface brief. In the brief, actually this command just shows the interfaces briefly, doesn't show any other information, just the interfaces. You can see this port channel is down here, and but this two port is up. They are functioning normally, there is no problem with them, but the port channel is down because the other side is not configured. And for this, let me show you one other command here. Show interchannel summary. In the interchannel summary, you can see that we have a group 1 as we select as a port channel 1. Then this is the port channel 1 and SD. S means that this is a layer 2 because it doesn't have any IP address, of course, it's layer 2. And D means here, let's see what is the D means. D means is down. It means that this port is down, and this protocol is PACP, and the ports that is added to this is gigabit 01 and 02, and they are in the I state. I means let's see what is the meaning of I. Is a standalone, means they are just yeah, they are a standalone. They are there is no any port in the other side to converge with that and create a port channel. Okay, let's now go to the other side and try to build a port channel in this side also. Before that, let me show you something. Let me try to run a ping from this side to, for example, to PC 7. I'm going to do that with the -T, and this ping will continue here. Okay, now because there is a normal trunk here and we don't have any problem, and this ping is working, there is no problem. But let's assume that we just lose this port. This port is down for any reason. The cable is broke or anything else. Let's shut it down. Interface gigabit 0x1, and let me shut it down. When I shut it down, you can see that the ping actually interrupted here, and now we cannot send any packet. The request time out, and this port is down. Now these two switches only have one connection, and the spanning tree now here trying to discover any port change here. Because the port is down, now the spanning tree just opening this port to make this connection working. But during this time, you see that we just losing our packet here. Yes, we just lost 5 packets. 3 5 packet here, and then the port is open now, and now we can ping for the other side. Now we have just a small interrupt here. Let's turn it on, no shutdown. And again, because again this spanning tree trying to discover the changes here, and now you can see this ping again interrupted because it's going to select the block port and the forward port. Then it takes some time for that to select this, and after a moment you can see that this port again become up, and this port will be down, not down, and the blocking state. Let's wait for that. We lost 4 ping, 5 ping, and after 5 ping, 6 ping. Okay, we just lost 6 packet here, and then our network just come up, and this port is again become up here. Let's leave it like this, and its ping is continue. Let's go to the other side and try to configure the port channel pack P here. Interface range gigabit 0/1 to 2, and then channel group 1. This number actually doesn't need to be in the same in the boot side, because it's just a channel group and it's a group. We can make 2, 3, or any number here and any number here, but the good practice is to select the same number, because in the troubleshooting that will help us and will not confuse us about this number. Okay, let's select the mode, and in this I can select the desirable, and it will open the actually build the port channel between these two without any problem. But I'm going to use auto here. Auto, again, it means that this port is just waiting to receive information from the other side if the port channel is enabled in that side. If I select as auto, you can see this port become orange, and the port channel now is up. You can see this port is flip up down, and now the port channel 1 in state is up. Okay, it means that the port channel is up. Let's check it. Do show IP interface brief. You can see the port channel is up here, and also this 2 port is up here. And if we check the show ether channel summary, in the ether channel summary you can see that S again, it means the layer 2, and U means it's in use. It means it's up now. And now this flag is also changed from I, if you remember, it's a standalone, to P. P means that they are in the port channel, and they just negotiated, and they just create a port channel. Now if you see here, this orange light is just gone, and we now have a green port here, because this 2 port now is a 1 port, and spanning tree doesn't do anything here because they are working as a 1 port logically. All the traffic is now, it's sent from this side to this side, will send through this link. Okay, let's go to the ping. You can see that our ping just continue without any problem. And in this case, if we just lose one of these ports, let's shut down one of these ports. Shut down again. We are in the port gigabit 0/1, and now it shut it down. You can see that this port is down and it's become red, but the ping doesn't interrupt it. It's just working fine, and we don't have any problem, and it's working correctly. There is no any down here. Let me yeah, you can see it's moving, and there is no problem here. Now let's turn it on again. No shutdown. In the no shutdown, there is no problem again. Now our ping will continue without any interruption, because now this is a port channel, and spanning tree doesn't have anything to do here, and port just turn off and turn on without any problem. You can see in just a moment this 2 light will be green, and the port channel will function normally, and the ping is continue. without any interruption. Okay, you see that we just lost a link here, but our ping just continue and we don't have any problem. This is very important to have a redundancy between your switches, because I know someone and he told me that 2 is 1 and 1 is none. It means that if you have 2 ports here, it's easy to just lose one of that. If you lose one of that, then you have only one port, one connection between these two. And if you have only one in here, and if you lose that, then you have nothing, then your network will completely down. In this case, it may not be a big problem, because from one floor to other floor, it may be relatable for the user to just wait to this link come up. But for some very critical systems, and people actually never wait for you to this port come up. You should make your design in such a way that you make the downtime as less as possible. And you can see that most service providers says that they have 99.9% uptime, and it is very important for everything, for business, for your authority as a network engineer. It's very important. Okay, now we just configure our PAC-B here, and if we check the port channel here, let me show you something else here. Show run. Okay, in this show run, you can see that now we have the port channel here, and this port channel, now this information, it's a switchboard mode trunk and switchboard trunk native VLAN 10. If you remember, we just make a native VLAN in the previous video as a VLAN 10, and also we just configure this port as a trunk. And this information actually is inherited from these 2 ports. When we add these 2 ports to this port channel, this information will automatically come to this port channel interface. And okay, trunk is still on its place. We cannot remove the trunk here, because we are going to send this different VLAN traffic from one port. Then it doesn't matter it's a Ether channel or it's a physical port, the concept is same, the trunking concept is same, and we need to have the trunk in this 2 port here. And this information actually comes from these 2 ports when we configure them as a trunk. Okay, let's do something now. We just configured the PAC-B here. Let's go for the LACP, the Link Aggregation Control Protocol, and configure that also. For this, let's first remove this 2 port. I'm going to remove that and then continue our video. Okay, I just removed the configuration from Ether channel PAC-B here, and now we are in the normal state, and they are the normal trunk, and the spanning tree actually it's doing its job, and just block this port here. Let's configure the LACP here. For configuring the LACP, the configuration process is the same. Let's go to the interface range gigabit 0 by 1 to 2, and then enable the channel group 1 and then the mode. In this, you can see that we have the passive mode, active mode. Let's get back to our presentation here, and let's go to the next slide. Here the LACP, the Link Aggregation Control Protocol, it's an open standard, and it's going to send the multicast traffic to this MAC address. This is the multicast MAC address. And also switch and router, you can see here that the router is also here. It means that we can create a layer 3 Ether channel also. Actually form Ether channel in the different mode of the this different mode here. It can be active or it can be passive. If our we select our port as active, it means this port actively send the information for its port channel to this multicast MAC address. And if the other side is configured as a passive, the passive doesn't send any information. It's just waiting to receive information from other side if there is any LACP is configured in the other side. and actually it doesn't discover anything. This one is trying to discover any LACP configuration in the other side. It's exactly like PACP. There is no difference between these two, just this multicast MAC address is different, but it's everything is same, just the concept is active and passive. Okay, let's go to the configuration and try to configure this one also. I'm going to select for the mode as active, and you see that this port is up and down, and now everything is same. Do show run. You can see that we have the port channel here, the port channel 1, but it doesn't have any information about the trunking because actually the port is down. Do show IP interface brief. The port is down because the other side is not detected as any LACP protocol. Let's go to the other side and configure this LACP in the other side. We are already in the interface range here, gigabit 0 by 1 and 2, and then let's configure the channel group 1 mode. This time I'm going to use this passive. This passive means that this port is passive. It doesn't send any information about its configuration for port channel, and it's just waiting for the other side to send its information. If any LACP is configured in the other side, then it will receive that information in that this MAC address, this multicast address, and then it knows that this information is belong to LACP and try to configure himself as a LACP. I just press enter, and now this port is up down, and in a moment you will see that the port channel will be up. Let's wait for that, and it may take some time because now this port is trying to negotiate. Yes, now the port aggregation protocol, link protocol and interface port channel 1 changes state to up. And if I run the show command here, do show run, here you can see that this port channel 1 is configured, and now it has the information for trunking, and this information, as I said, it just come from these two port that we configured before. And you can see in this side the port channel is passive, and here the port channel in the other suite the port channel is active. Do show run, and here you can see the port channel mode is active here, and now we have again a port channel and we don't have any problem. Now this two port is working redundant, and if one of them is down, the other one will take the place and will send the traffic, and when the other port is come up, then it will join to the ether channel and send and receive traffic. But it's not like PACP. In the PACP we didn't have any interruption between these ports, but if I just turn off one of these ports, losing the port, there is no interruption, but the port, when the port is come back, then it will be some interruption between the ping, and I'm not going to do that. You may test that on your own lab. Okay, and now we have the LACP and PACP configuration, and let's go to the other mode also. This one is a manual mode. It means that we just select the mode on. When we select the mode on, then this port channel will not negotiate for any protocol, and it just create this two port here in this diagram. This two port has a port channel, and on both sides it should be on in this side and on in this side. Then the port channel will form, and we will not have any problem here. And I'm not going to configure that also. It's the same configuration, just in the mode we are going to select. If I just go here, channel group 1 mode, you can see that we can select this on mode, and it's enabling the ether channel only, and it doesn't negotiate anything on the port. but it has some drawback for this, because there is no protocol actually is negotiated here. And if we have any for example modem or any media converter in the middle, this media converter actually it's not able to understand this port channel. You know what is the media converter? Maybe this port will be too long and we may need something here to actually repeat this link, and that called media converter. And also maybe we need to convert one side to other side as from copper to fiber and from fiber to copper, and there is a device it's called media converter, and it will use in the between. If we have something like that in the between of these two, then that media converter will not be able to diagnose the device if it's any failure in the port channel. Let's do something actually. Let's configure this port as on, and because okay, different protocol is already configured and it doesn't accept me, we need to remove that and then configure that. Okay, you can do it at home, and there is no much difference between these two. Just enable the on ear, and on ear then it will form a ether channel between these two ports. Okay, I believe our video is finished here, and we just configured the ether channel between these two ports, and now we have a 2G link between these two switch, and we can send our traffic very efficiently from one side to other side, because we already have actually two ports connected to this. Then why we should not use this port as a actually as a main port? Then we just configure them as a port channel, and it's create a tunnel between these two, and now this traffic from this side to this side will send from two different interfaces. And also we don't need we also have our redundancy here and also our trunk here, and we didn't lost anything. Everything is okay, and we just have one more option, and that is the ether channel for having a better bandwidth here. Okay, let's finish our video here, and please follow us in the channel for the future video, and in the next video for this series, and I will speak about another subject in the CCNA. Thank you for watching, and see you in the next video.